Okay, so what were we doing yesterday? Screen sharing, sure, of course. Okay, can you see that now?
Yes, sir.
Sure. So what were we doing yesterday? We were talking about selection or order statistics. We also call the selection problem. And what is the problem? You have n elements. Find the ith smallest element. Right? That was the problem. And we discussed what are the solutions for this problem for I is equal to 1 and simple comparisons. And as you keep on increasing I towards n by 2, so I is equal to 1, this is very simple. I is equal to n, it is very simple. But yeah, this complexity will increase. And generally, it looks like that becomes maximum in the middle. So that means finding something like median is most difficult. Yes. And we said in general for any I is equal to k, you can use some things like heaps. Yes, so and we saw that you can do in order n plus k log k, and there's another one with order n minus k log k plus n. Yeah. So actually, I was just thinking that overall, I still feel that this would be better than this algorithm, because even if you have k greater than n by 2, right, you can do it the other way around. You can, if you are using max heap, you can use min heap and vice versa. But here you have n minus k and k. That's why even if k is less than n by 2 or greater than n by 2, one of these terms will create difficulties. But here you have k log k. If you have k greater than n by 2, you take the other way around. You do the n minus k log n minus k. So, but yeah, both are roughly same. But we want to do even better than that. We want to do better than both of these. So this is what we saw. Using heaps, we can come to something like order n plus k log k. But then we had the question, can we do it in order n time? So possible to do it in order n time. And that is interesting. That means what I'm saying, you are given an array, arbitrary array, you can find median or whatever ith smallest element in order in time. And the question is, like, looks very promising if we can do that, but how exactly we can do that, right? And that is where we said you can use a variation of quicksort, right? We can use a variation of quicksort. So we start with a variation of quicksort. Use pivot and transform the array. Okay, and then you do recursively, you do selection in either left or right. Recursive selection in left or right partition. That is what we said. This looks like a very good algorithm. You can do recursive selection in left or right depending on what is your k. You have I is equal to k. So this is n1 and this is n minus n1 1 minus 1. And depending on what is the value of k, you can do recursive selection. Was that idea clear to everyone? We can use a variation of quicksort. Because whatever I tell now will depend on that. Okay. So I assume that is clear. We also discussed, okay, best scenario is, what is the best scenario? How would we achieve order n by using this algorithm? How can we
Both
achieve
left
order
and
n?
right are comparable.
So idea is both left and right are comparable. By that you mean they can be expressed as some fraction of n.
Yes, sir.
Both can be expressed as some fraction of n. And even if it is 7n by 10, 3n by 10, 9n by 10, n by 10, I'm fine. Then also I'll get O(n) worst case. Now the question is, fine looks fine, so what? How would we ensure? How would we ensure in any arbitrary case that whatever pivot you take, the left and right partitions are balanced? How can we ensure that? You have to ensure that. For the worst case guarantee, you have to ensure that. You cannot say, oh, in general this will happen, or on average this will happen. You cannot say that. You have to ensure that each one is a fraction of n, or at least larger than a fraction of n. Okay, so how to ensure that? And that is where you have very interesting algorithm. So and this will give us a linear time, worst case. And that is where we have a very nice algorithm. So given by actually 5 people, Blum, Floyd, Pratt, Rivet, and Tarzan. So they gave a very nice algorithm, and actually it has something to do with 5 people. So algorithm actually uses 5 as a nice concept. So what is that algorithm? So you see the algorithm is same that we discussed, okay? Same algorithm that we discussed using a variation of quicksort. What changes? The interesting idea is how to select the pivot. That's where you can do innovation, how to select the pivot so that the 2 partitions are at least a fraction of it. So what they are doing. So I'll just tell you what will happen at the end. So what you will see at the end. So finally, you will see that we will show that each partition has elements greater than or equal to some 3n by 10. If n is the total elements, each partition has elements greater than or equal to 3n by 10. Okay, so that means the next time you go, you have to call something like T of 7n by 10. Okay, so this is one thing. And then there's another thing. For doing this algorithm, you have to make a recursive call to your original algorithm. You have to make a recursive call. Selection algorithm. And that you will do for n by 5. For an array of size n by 5, you will do a recursive call. Okay, so finally what will happen? Tn will be T of 7n by 10 plus T of n by 5 plus On. And you can see that you can verify this will be On because the terms in n are less than, they are not adding up to n. This is still less than n. They are 9n by 10 roughly. So this actually gives you an ON algorithm on solving. So just they ensure that at least n by 10 is removed every time. You start with n by 10 is thrown out in the worst case. Maybe more, but yeah, this is a guarantee that n by 10 will be surely thrown out. So that means you have an ON worst case algorithm. Very
Sir, I didn't get how we are making
how we are?
doing this. Sir, how to
Yes.
ensure?
So I just told you the finally what you will get this. Okay, now, so I just told you the final result so that now you have this question that you have, oh, how we will do that. So now let's come to that question, how we will do that. Okay, okay, how we will do that. How? Big question. Okay, so you will see the idea is very interesting, very nice, and not very difficult. So what do we have? So we have an array of n elements. Now they use this 5. I said they do something with 5. So what they do? So first thing is divide the array into n by 5 groups of 5 elements each. Of course, except the last one that may have less than 5. Except the last maybe. So what you are saying, you are dividing into n by 5 groups. Okay, yeah, to be precise, I can even write a n by 5 ceiling, but if you don't mind, I'll not worry too much about this. So just a factor of 1. So G1, G2 up to G of n by 5, n by 5 groups of 5 elements each. Now each of this group has 5 elements. Okay. Five elements. And they don't have to do anything. They can use the indices to do the grouping. So this is like trivial thing. Okay, doing the grouping is trivial. Fine. Step 1, okay, do this something with 5. Now, second step. Find median of each group. So that means G1 has 5 elements, you can find a median, right? So suppose this element suppose is the median. So like that each group will have one median. Find median of each group, so you get n by 5 medians. How much time that will take? Finding median of each of these n by 5 groups.
Ordering.
Order n is fine, but what would you use for this? What algorithm will you use?
Order of statistics.
Hmm? You have to find n by 5 medians each of 5 elements.
Sir, we can sort and return the third element of array because number
Ah,
of
you can do
elements is
many
very
things. You can do many things. And I think, see, because you have to do only for 5 elements, so even things like merge sort will not be efficient for 5 elements. So what you will do, you can do simplest algorithm that you can think of, maybe an order n square algorithm, doesn't matter. So you will use an O of k square algo something, and you are in cage 5, k just 5, and do it for k by 5 groups. So this will give you, say, from something like 5k. 5n. 5n. It's still order n overall, but yeah, this is what you can do. Even if you use an order n square algorithm for finding median of each of the group, you don't lose much. You still get an order n way of finding this. Okay. Find median of each group, right? Now what you have is n by 5 medians. Now third step is recursively call your selection algorithm. So overall the algorithm we are developing is we are calling it selection algorithm. Your selection algorithm for finding median of these n by 5 medians. Okay, and that is where sometimes the name of this algorithm is also median of medians. So you have an algorithm that takes some time and you pass the n by 5 medians to that and you get a median. Okay, so fine.
Sir, will this give correct answer?
Huh?
Will this give correct answer?
What
Because
correct
finding
answer?
median of median won't ensure always. Like, if the original median is not the median in one of the groups.
No, no, no. See, I'm not finding median. I'm finding the kth element. See, that is where it's very important to understand this idea. See, you find the median of these n by 5 medians. Okay. Your original task. What is your original task?
Finding the kth element.
Kth element. So now the fourth one is just trivial thing. Now take the answer of step 3 as your pivot. Wow. And this pivot goes back to your quicksort inspired algorithm and feed it to your quicksort variation. So you're not using it to finding this step 3 is not for finding median. It is only to find the pivot. Okay. So you use that pivot in your quicksort variation. Now you have some guarantee that okay, the left and right partition will have some fraction of n elements. And then you have a guarantee that the left and right partitions will have at least 3n by 10 elements. And once you have this guarantee, oh, you are very happy. You're very happy.
Sir,
Yes.
sir, like why at least 3n by 10, sir? Why can't we say that half of the elements, sir?
Yes, yes. So I'll come to that analysis now.
Okay, sir.
I'll come to the analysis. Because of the point the previous person just said, that this will not be a median. You're finding something, this will not be an exact median of the array. Yes, and that is true. This is not the exact median. It's just something we are finding, but we are ensuring that at least 3n by 10 will be less than that, at least 3n by 10 will be larger than that. Okay, there will be more, but at least these many. Now let's do analysis. How do we show 3n by 10? At least 3n by 10 elements are smaller than a larger. Okay. How? Why? That is the most important thing. Why not n by 2? Like you were saying, why not? Why can't we say n by 2? That will even make a more stronger case. Why we are talking about 3n by 10. Okay, so let's analyze this. Okay. So what have we done? We have an array of n elements. We found n by 5 groups. Each group we found a median, right? We have n by 5 medians. We found median of that. So let's do the analysis. So we have G1 to G of n by 5. Each GI has 5 elements. And you found the median. See, the individual algorithms are correct. Finding median for each group, that algorithm is correct. Finding median of all medians, that is also correct. Okay? So both algorithms are correct. They will give you the correct answer individually. Okay? Because you are using the correct algorithm. You are saying, oh, 5 elements, I want to find a median. Exact algorithm. You're not making any assumptions. So those 2 algorithms individually will give you the correct answer. Based on that. So I have n by 5 groups. Each group had a median. Okay. Now I took these n by 5 medians, and gave it to my selection algorithm, and that gave me what is the median. I found a median of this. And suppose this element is x. It will be some element, suppose this value is x. And let's assume they are all distinct. So what can you say? How many elements are, say, smaller than x? So now, how many elements are guaranteed to be smaller than x?
So 2n by 10.
So n by 2 minus n by 5, approximately.
N by 5.
Hmm?
N by 5.
Okay, let's go step by step. So this x is a median of n by 5 medians. That means I'm just not using a constant one. If you want, we can do that. So that means n by 10 elements, n by 10 medians are smaller than x. Okay, this exact will be n by 10 minus 1 or minus 2. But yeah, those 1 and 2 will not make much difference. So n by 10 medians are less than x. Do you agree with this? In this array, roughly n by 10 are smaller than x and n by 10 are larger than x. I can use minus 1 and that will be exact, but yeah. Do you agree with that?
Yes, sir.
Yes, sir.
Yeah. Yeah. So okay, so we have no difficulty at this point. N by 10 medians are smaller than x. Now, these n by 10 medians itself were part of some groups. Okay, so any median here will be part of some group. This will be part of some group, and so on. So consider a group that a median is part of. Suppose a median is part of a group here that has 5 elements. Now what can you say? So you got this median. So suppose this was y. This value is y less than x. Now what can you say about that group?
We have at least 2 elements larger than y and at least 2 elements smaller than y.
This group will have at least, actually you can say exact also, but yeah, will have at least 2 elements smaller than x is smaller than y, and which implies 2 elements. Yeah, at least 2 elements.
Sir, should we say at least or at most? Because we have 5 elements, and if some are equal, then it will be greater than 1. Like it is 1, 1, 1, 2, 2. Then 1 will be the median.
See, right now I'm assuming they're distinct. If you want to consider them to be same, you can say less than equal to. Less than equal to. That is also fine. And here I'm just taking the distinct. So at least 2 elements are less than y, and that implies at least 2 elements are greater than, sorry, less than x. Now this will happen for all medians except the last one, last group. Right? Last group may have less than 5 elements. Okay, so this will happen for all groups except maybe the last. Yes.
So it will be at least only because it might happen that there is some element less than y, but which is not present in this group.
Hmm? No,
But we are speaking only of that group.
no, I did not understand that. So I'm saying y is one of these n by 10 medians. It will have a group where y is the median, right? So it will have 2 elements less than y, 2 elements greater than y. So I can say, actually I can say this will have exactly 2 elements less than y. Yes. And because y is less than x, that means this has at least 2 elements less than x. At least because, yeah, some elements here may also be less than x. They are greater than y, but less than x. But we know at least 2 elements are less than x. This I don't need to say exactly. Yeah. I'll wait. Is that something that you agree with?
Yes, sir, it is fine.
Sir,
Yes.
sir, when we say median of medians, we mean that we are recursively dividing it into groups of 5 and we are finding the median and like so on recursively.
Yes, everything. Yeah.
So like as we said before that this median is not exactly the median, like
No, 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 no. So you have to be clear what I said. I said we are solving a selection problem. Okay. Let me again clarify that. I'll come back to the analysis. Okay. So we are solving a selection problem. What is the problem? Problem is you will be given array of size n, and you will also be given some k. Okay. And you have to find out what is the k, the smallest element. That is the algorithm you're developing overall. And we are showing that this will take O(n) time. But let's say this is an algorithm and that has a complexity of Tn for an array of size n. But you can pass any k. Yes, so this algorithm is there. Assume there's an algorithm, right? That we are actually developing. But suppose there's an algorithm. So when I said recursively pass each n by 5, what I meant, you call this algo recursively, call this algo, so something like you have an algo, say selection, you give the actual array A, maybe other things, but at least K. At least 2 things are needed. Array and what is K? I want K, the smallest element. And this is an exact algorithm. This will give you the correct answer, right? So this algorithm is there. When I said you recursively call this algorithm on n by 5 medians. So suppose you have an array, you define this array as n. Yes. So you call this and you see whether, yeah, just for now, let's just say that this will be You don't care so much about taking the average of two medians. So just say you want to call it once. Average is not so important. So you call this with selection A, oh sorry, M, and so n by 10. So you want the n by 10th element. It's not exactly the median in the sense of if it has even size, what I will do. So this is what I meant. You recursively call this algorithm. This will give you the exact n by 10th element of the array n. N by 10 the smallest element of this array.
So
what
to
I
find,
said, the one that you will get may not be a median of A. This will actually not be a median of A. But this will actually be median of M. This will be median of M. This will be median of M, but not necessarily median of A. That's what I meant.
So, sir, after getting those n by 5 medians at the first call, we'll divide those n by 5 elements again into groups of 5, so n by 25 groups, and we'll find median of each those.
You don't do that. Your algorithm does that. It's a recursive call. Your algorithm is only defined for the case. You divide into 5 groups, fine, and then recursively call it. You don't care about n by 25, n by 1 by 25. You don't care about that, right?
Yes, sir. I mean, I'm not able to understand why that the new one which we got will be a median of M also. Like, I feel it shouldn't be a median of M also. We can't say that. Like, we can't guarantee that.
You see, because okay, fine. You need to see the bigger picture now. Okay. So what is your algorithm, selection algorithm? Okay. I'll again tell. What is your selection algorithm? I'll again tell the steps, what you will do, step by step. So you have this problem, okay? What will you do? First, once you have this algorithm, what will you do? Find pivot X. First thing you will do is find pivot X, okay? Second, once you find the pivot X, you will partition. Based on X, you will partition. This is less than X, greater than X. What we are showing here, each partition will have at least 3 n by 10 elements. Okay, and you have partition, then you find out whether I will go into left array or right array, depending on this is size n1. If k is less than, k is less than n1 or k is greater than n1 plus 1, depending on if that you will go into left or right subarray. Yes. What was missing there? How to find pivot such that, and you see this algorithm is exact. This will keep on going recursively into left or right subarray and will find you the exact kth element. I want you to again think about that. Do you think that will happen? Once I find a pivot.
Sir, shouldn't it be k less than equal to n1?
Yeah. So think again with a cool mind. Yes, this is all we are doing. This is my quicksort variation algorithm that I'm doing. Okay. And this is what I meant is the selection algorithm. This is my selection algorithm. You can give an array A and you can give K. I want kth. K is the smallest element in this array. And this will do this. This will do only this much. And will give you exactly the value. Do you agree with that?
Yes, sir.
Now the question is, how do I find pivot X? For finding pivot X, what you said, okay, for step 1, okay, how will I find pivot X? I said, okay, for that I'll write some more code. Step 1, you elaborate, find pivot X. For that, what you will do, you will say, okay, I'll divide my array A into n by 5 groups. I find median by some simple method of each of these n by 5 groups. I create an array M of size n by 5 medians. Okay, so this is what elaboration of step 1. This is all you are doing in step 1. Now, once you have this M, then you call the selection algorithm again. Selection algorithm on M, and you want finding n by 10. N by 10th element of this M. Okay, the selection is an exact algorithm. This will give you the n by 10th of M. N by 10th is smallest element of M. Now tell me, where have I made some mistake or something is not clear?
Can you explain that selection part, the M
Yeah.
comment?
Yeah. This one? You want this one or the below one? This
The below one.
below one. Right. Right. So in step 1, what you are doing, you have to find the pivot X nicely to make the guarantee. So what you are saying, okay, I have the input and my array of size n, right? I'll divide into n by 5 groups of 5 elements each. I'll find median of each group. So I'll get n by 5 medians. Yes. Then I want to find their median. I want to find their median. So what I will do, I need an exact algorithm for finding the median. So I call my selection algorithm again. Selection algorithm with this array m and n by 10 as the parameter. I mean, I want the n by 10th smallest element of m. And whatever you obtain, this is your answer. This is your answer. X is equal to this. And you found your pivot in step 1. Yes, now you partition your array based on the pivot and you continue.
Sir, what was our initial call of the function? Is it a comma n?
A comma k.
A comma k.
I want the
Okay.
k at the smallest element. I want a general algorithm, right? I can find any k at the smallest element.
Sir,
Yes.
sir, to find the median of these n by 5 medians, we will have to create additional array, right? Because how will we say, means we have to create the array M separately. So means, is there
Yes,
any
sir.
way in which you can do it in place, means directly without creating additional array?
See, I don't think so in general. See, what can happen when you're finding the median of each of these groups, you can do in place things, right? You can sort them, suppose you're sorting them. So you will ensure that the third element each is a median, right? And when you go further, you may even use the fact that the third element and at a distance of 5, they're all actually the elements, okay? But you cannot ensure that in the last group. In the last group, there will be less than 5 elements. So yeah, it seems that you have to find out, you have to actually create a new array and do that.
Okay, sir.
Yeah, that is my feeling. Maybe somebody has a trick for doing that, but I think you have to create a new array. That's my feeling, but yeah, we can check if there is some more ideas to do it in place. So yeah, basically because of the last group, I think. Otherwise, you can somehow encode the distance, maybe, and pass through parameters. Okay.
Sir, so when we call selection m comma n by 10, then we again find a pivot for this selection. So we'll
Yes,
again
so
have
this
to
we have
divide this.
all this. So see, this is recursive. See, that is the good thing about recursion. You forget, or you don't go deep into recursion. Let the program do that.
No, sir. So I'm asking like then again it will divide the array into 5
yes,
elements.
yes.
So again, how it will ensure that it is the median?
What do you mean? It will do nothing. It will see when you call it again, it will find a pivot. It will find a pivot. Okay, some pivot. See, this algorithm gives you the final answer. If the whatever be the pivot, this algorithm that we are talking, step 2 and 3, will give you the correct answer. Take that. Does not matter what is the pivot. You take whatever pivot you want. This algorithm gives you the correct answer. Now first, make sure you agree with that.
Yes, sir.
So this algorithm gives you the correct answer. Yes.
Sir,
Yeah,
all this word partition and this decision making, sir, all these things will be done in selection a comma k function.
Yeah.
Okay, sir.
Everything is being done in selection again. Okay, and you have to now you should be clear that this gives you the correct answer, right? Only thing is what we are saying, pivot may not be the median of the array. Fine, who cares? As long as this is at least 3n by 10 and 7n by 10. Fine. It's not median, but it is at least some partitioning. It is ensuring some partitioning. But this algorithm gives you the correct answer. Right? That is something that, yeah, you should know better than me. Yeah, this algorithm gives you the correct answer. So, whatever k you give. Okay, so now this is the bigger picture, and this is what we are doing. Okay, and then we were into the analysis where we were saying, okay, I'll again remind you what we said. So we have n by 5 medians, and the median of this, the exact thing, is x. So I know that around n by 10 elements are less than x, n by 10 elements are larger than x. Now for each of these elements, this is one of the medians, right? You go to its corresponding group that will have 5 elements, y with a median. So that means 2 elements will be smaller than y, 2 elements will be larger than y. So that means this group will have 2 elements less than y and y is less than x. So at least 2 elements less than x. So overall, what can I say together? 3n by 10 elements are smaller than x, and 3n by 10 elements, same thing, are greater than x. Can I say that?
Sir, you are taking distinct elements. So,
distinct elements, yeah.
So, sir, what about the rest?
Rest means
We have total n elements, and 3n by 10 are less than x, 3n by 10 are greater than x.
No. Okay. At least. That's what I'm saying. At least 3n by 10 are less than x. At least 3n by 10 are greater than x. Others can be anywhere. That's what I'm saying. So because we are getting guarantee.
Sorry, Ishira, can we divide?
into n by,
Mhm.
n by 5 groups, then for each median, we'll have 2 elements less than that median, no, sir, for each group.
Yes. For each group, we have 2 elements less than that. Yes.
So we'll get total of 2n by 5 elements.
2n by 10. There are n by 10. They are part of n by 10 medians. N by 10 medians are smaller than x. For each of this, there are additionally 2 elements that are less than y. So together there are 3 elements in each of these medians. 3 elements in each of these n by 10 medians. So there are 3n by 10 elements. Less than x, 3n by 10 elements, and they are at least. This is guaranteed.
The at least for greater than x may not be true.
Okay, so actually, if you want to be exact, this will actually be 3n by 10 minus 7. I avoided all that because you need to do a lot of flooring, ceiling, and all that. But this will be 3n by 10 minus 7. Okay, this doesn't make any difference in the final thing, but yeah, this will be 3n by 10 minus 7.
So how will that 7 term come?
Mhm.
How will that 7 term come? Like I am assuming the array to be the right side of each partition.
The thing is that when I say n by 10, see, n may not be divisible by 5. And so you have to take that into account. Then the last group may have, say, 1 element. So you have to take all those things into account, and this will come to be 3n by 10 minus 6 minus 7 around that for both of us. And actually, yeah, so when I say 3n by 10, I should say this something like n by 5. You take the ceiling, then divide by 2, again take the ceiling, and yeah, minus 2 times 3. So this was the actual expression. So that you get. Okay, and yeah, I really did not want to go into the ceiling business and this, but yeah, so this approximately, yeah, you can say 3n by 10 minus 6. I think in 6 or 7, one of the cases 6 or 7, this is what you get. Because you would take the ceiling to get the actual integer. Uh, that many groups will be there, n by 5 ceiling. And so yeah, I should say something like greater than or equal to 3n by 10. That's why you say at least 3n by 10 minus 6 elements are greater than x, at least 3n by 10 minus 6 elements are smaller than x. Okay. Of course, if
Sir?
you want
That if we divide the group into smaller groups of more than 5 elements, then it might happen we may get greater than, I mean, good bound.
Sure. Okay, let's first get a bound for here. Okay, let's first get a bound here. So right now I'll just work with 3n by 10 just to make it easier. But you have to be clear. This is actually some minus 5 minus 6. So some constant is there. So okay. So now what is the complexity of this algorithm? Complexity of selection. So Tn. So let's see how much work. Find pivot x. How much work do you do? N by 5 groups, divide, find median of each of this, all in order and time. Till now, order and time. Yes.
Yes,
No?
sir.
ON. Now this one, calling selection again on array of size n by 5. You're calling it on an array of size n by 5. What is the complexity here?
T of n.
T of n by 5. Step 2 and 3 together. What is the complexity?
Order n.
Doing partitioning, order n. ON. And then you are recursively calling. Recursively call on one of the subarrays. what will be that? This will be less than or equal to T of
3n by 10.
no.
7n by 10.
Yeah, the worst case is 7n by 10.
Yes.
In the worst case, you have to see what is the largest subarray you can go to, 7n by 10. So then you get something like Tn is equal to or less than or equal to Tn plus, oh sorry, Tn by 5 plus T of 7n by 10 plus ON. And if you solve, this comes out to be solving, you get Tn as ON. And the simple reason is because the terms here add up to 9n by 10 less than n. It's a fraction of n. It's a fraction of n. So that is why you get ON algorithm. Yeah, that is the analysis. So
if they add up to n, then
yeah, no, then you don't. Then you get something like n log n. Yeah, merge sort does that, right? Tn by 2 plus Tn by 2. Quick sort also, if you do, suppose in quick sort we said
yes.
Tn as T of 9n by 10 plus T of n by 10 plus ON, that gives you order n log n.
Okay, sir.
But if these two terms are a fraction of n, then you get order n algorithm. Very interesting. Yeah. So that is what is the difference in the quick sort. So you see, one thing that you can learn from this algorithm is that, oh, now you have a way to make quick sort order n log n, isn't it? You can now run quick sort in order n log n if you want to code on this. Yeah. So yeah, you can actually give a guarantee for quick sort now. I have a way to find a pivot such that the quick sort will actually run in order n log n. Okay, so this is where, yeah, this is where is the main central algorithm for order statistics. You can do selection in order and time. So it's already close to 10, right? So that completes the syllabus also. That completes the syllabus also. To make up for all the extra hours we have taken on Wednesdays and sometime on Friday. So few days before. Now tell me if you have doubts about this algorithm or anything, I can surely come tomorrow and discuss. It's up to you. If you have doubts about this algorithm, you have some more questions, I can come tomorrow 11 and we can do that.
Sir, sir, why are we partitioning it into 5 elements in each group? We can do
Why
better
not?
than,
So why not?
I mean, 7 or 8 or 9, greater than 5.
Very good question. Why not 3? Why not 7? Why 5? Yes? Or why not 9? Yes, that is the question.
Yes, sir.
Okay, so do you want me to answer that tomorrow? I can answer right now, but
Yes,
it may
sir.
take some more time. And I don't know, you may have a class at 10. So sure, let me then come tomorrow and answer this question. Okay, to do. Answer is actually very interesting. Okay, it's very interesting answer. And I think, yeah, let's do that tomorrow. And what you will see, 3 will not work out. 7 and 9 are good, but there is some issue that we will see. Okay, but yeah, it's a very good question. Take around 15-20 minutes. Yeah. And then maybe I'll then bring also some questions we can do tomorrow.
Sir?
Yes.
If we use this algorithm for quick sort, then the partitioning will be 3n by 10 and 7n by 10, right? For each case.
Yes, yes. So that means you will have, yeah, Yeah, 7n by 10 plus 3n by 10 in the worst case.
Okay, sir.
And doing this algorithm, calling this algorithm will be ON again to find the pivot is ON.
Okay, sir.
Okay then, so yeah, we will meet tomorrow 11. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.